One of the challenges people face when they're building and maintaining APIs is how to handle change. This is something that gets discussed in depth, and there's a bunch of different strategies out there. However, today I want to discuss a different approach. It lets producers evolve their APIs independently, even introducing breaking changes, without consumers having to do a bunch of work. It's a strategy that's language agnostic, so it works with OpenAPI, Protobuf, Avro, SOAP, or a mix of all of them. It lets teams build powerful, federated APIs that self-heal as producers evolve. And best of all, it's entirely open source. So today, let's talk about avoiding breaking changes by using semantic metadata. Before we dive into a demo, let's take a quick look at how this all works. Now, I should point out that the strategies I'm talking about today are really designed for APIs and data sources shared between teams within an organization. You could apply this on your public-facing APIs, but I don't think it'll work as well. So, it all starts with a producer who's emitting some data and a consumer who wants to use that data. The producer has an API spec. In this example, it's Protobuf. And the question is, how do we make changes on the producer without causing problems for the consumer? Now, the issues arise because in order to read the data, the first thing consumers do is take the producer's API spec and embed it, usually generating some code. As soon as you do this, your producer and your consumer are tightly coupled. So changes made on the producer side cause the consumer to blow up. Each API spec has different capabilities when it comes to designing for change. Because we're talking about Protobuf today, let's quickly break down what you can and what you can't do when changing Protobuf messages. Protobuf is pretty strict about change. It lets you add new fields, so it's what some people would call forward compatible. And that's about it. Protobuf doesn't let you rename fields, remove fields, or even reorder fields without coordinating those changes with consumers. So it doesn't take much to introduce a breaking change. Protobuf, like most API specs, is what we call a structural contract. It talks about how data is encoded. It tells consumers the field names and the data types so that you get type safety between producers and consumers. Now, these are all the types of things that change as systems evolve. On the other hand, we have semantic metadata, which we build using an open source language called Taxi. Semantics are different. They don't talk about encoding or field names or IP addresses or port numbers. Semantic contracts are solely about introducing metadata that describes meaning. You can think of them as a collection of simple tags that you apply to your data at the field level, which assigns meaning to each field. Semantics are system agnostic and simply provide a shared set of terms for discussing data. Because semantics describe business ideas, not systems, they change infrequently. So, on one hand, we have structural contracts like Protobuf, OpenAPI, Avro, which describe systems. These are great for producers. On the other hand, semantic contracts describe what data means. These are great for consumers as they don't change when systems evolve. The idea is to take our structural contracts and enrich them with semantic metadata. Then consumers can create bindings to semantics rather than structure, so they're protected when the systems change. Producers publish their API contracts, enriched with semantic metadata, to a gateway. Consumers use that same semantic metadata to describe their data requirements and issue a query to a gateway. This is a bit like how GraphQL works today. However, this approach works with whatever API specs you're already using, like Protobuf or Avro, so you don't need to migrate to anything. It works with your existing specs. Also, it works across a whole variety of enterprise data sources, like Kafka topics and S3 buckets or Lambda functions, as well as traditional APIs and databases. Finally, and most importantly, there's no central resolvers to maintain as producers evolve. Everything is driven off of the API contracts that producers are publishing. The gateway here is Orbital, an open source data gateway. It's responsible for using the producer API specs to call producers and return data to consumers. The key part is that producers and consumers have remained decoupled, so changes on producers don't affect consumers. So here's my Protobuf spec, which describes orders placed at a food delivery service. You can see it's a standard Protobuf spec with our semantic metadata added in. We've published that to Orbital, our data gateway. I can jump into Orbital's query editor and ask for a stream of live data. So here's our raw data as it's coming straight off of the Kafka topic. However, I'd like to define a consumer contract which specifies just the data that I want in the structure I want it. So I'll write a new query. Stream order placed, and this time I'll specify the fields that I want. The ID, the customer ID, the name, the amount of the order, and the items. Now when we run it, I just get back the data that I'm after. The field names are defined the way that I defined them, and I'm just getting the data that I wanted to see. I can take this query and embed it into my application using an SDK. For now, we'll just copy it out and curl it. So here, I'll just curl the request. And here's my data coming off of the Kafka topic from Protobuf, returning the fields that I want in the data structure that I want it. So, now that everything's working, let's break it. This is our current version of our Protobuf spec with quite a few fields. Let's refactor that and move all of the customer data into its own object. Now, in a traditional Protobuf scenario, this is definitely a breaking change. We'll publish the updated Protobuf spec to Orbital and start producing data against the new spec. Back in the query editor, if I stream the raw data coming directly off of Kafka, I can see that it matches our updated spec. The customer data is nested under the customer field. If I look at my query with a data contract, the consumer is still getting the data in the format that they originally asked for. No breaking changes. Over in my terminal, I can see the query is still running happily, still serving data with my original contract, even though the producer has changed, without any disruption. Right, let's do another one. Here's the Protobuf spec as it is now, with our customer data nested. This time, let's rename those fields, so the field names are a little bit shorter. Customer ID becomes ID, customer name becomes name, and so on. Again, this is a change that would typically break consumers. So let's publish the updated spec back up to Orbital and start producing data against this contract. Once again, jumping back into our query editor, we can take a look at the raw data coming off of Kafka and see that the field names have changed. ID, name, email, country code. In our query with a data contract, when we run that, we see that the field names are still exactly the same. There's been no resolvers to update, no glue code to maintain. Everything's just adapted. Jumping back into our terminal, yeah, that's still running well, completely unaffected. Okay, let's do one last change, but we'll make this one a real doozy. Here's the current version of our Protobuf with the shorter field names. This time, we'll remove the customer data entirely from the message and just have the ID. Now, our consumers require customer data in their contract, so this is almost certainly a breaking change. If we jump back into the query editor and look at the raw data coming off of Kafka, sure enough, all of the customer data is gone. All we've got is just the ID. If we rerun the query with the data contract, that's still got customer data. But hang on, what's going on? That's not on the source message. Well, let's take a look at the query profiler to see what's going on. We can see that because our consumer is requesting customer data, and because it wasn't available on the producer's data, Orbital has added in another service to start fetching that data out. It's taking the data from our Kafka topic and feeding in to the customer service to look up the customer to fetch the name. Again, there's no resolvers I had to maintain or update to do this. Simply because the data was no longer available, the query adapted and started calling the HTTP operation to fetch the required data. Orbital was able to understand how to do this because of the semantics embedded in our API specs. Here, we can see the actual traffic. Orbital requesting customer information from our customer API, passing the ID into the path. There's sensible caching applied here too, so we're not spamming the upstream API with tons of requests. Sure enough, over in our terminal, everything is still carrying on, completely unaffected. So, let's recap. By adding semantics into our producer's API specs, consumers get a much richer and much more stable way of asking for data that doesn't require lots of heavy lifting when producer contracts change. Producers can introduce breaking changes, like renaming, refactoring, or even completely removing fields from data. And a data gateway can leverage the API specs to adapt, serving data to consumers and keeping them completely unaffected. So, next time a discussion breaks out about API versioning and breaking changes, you know there's at least one more approach to add to the mix. Thanks for watching.